Earthquakes are frightening disasters that affect lives in ways we cannot imagine. Some of the worst earthquakes occurred in this decade alone. To understand how earthquakes happen, let's take a look at the structure of Earth. The outer surface of Earth is composed of plates that glide over magma. When two plates get stuck, great pressure builds up. The rock underneath breaks, and all that pressure gets released in waves of energy which shake the ground violently. As with any disaster, the risk of an earthquake is a combination of hazard and vulnerability. Hazards are natural properties of an earthquake, things like its epicenter and intensity. Sadly, these can't be prevented. What engineers can do, however, is to design buildings to resist the hazard so as to reduce the vulnerability of people living in them. During earthquakes, ground shaking applies an acceleration on buildings which can exceed 0.5 g in severe cases. That's similar to pushing a building with more than half its weight, and buildings that vibrate and sway more have a higher risk of collapse. Civil engineering makes a critical difference in managing earthquakes. In 2003, occupants of Torre Mayor in Mexico City barely felt a 7.6 magnitude earthquake, thanks to a series of dampers that absorbed shock. In that same year, an earthquake of 6.3 hit Bam, Iran, yet 30,000 lives were lost when mud and brick buildings with heavy roofs flattened from the tremors. As human population continues to grow, more of us will be living near earthquake-prone regions. The world needs engineers who are willing to collaborate across disciplinary and geographical borders to save precious lives.